going to check on the visual pathway. The visual field has two components, the temporal visual field and the nasal visual field. And when if these are the two, right and the left eye. So the right visual field is the temporal, both for both eyes, the temporal visual field will project to the nasal retinal field, and the nasal will project to the temporal visual field. The retinal visual field. So the retina has layers, and the main photoreceptor in the outer nuclear layer receives the light, and in the photoreceptor, and these photoreceptors are the cones and rods. The cones will receive usually light in the when there is a light, and while the rods accommodate the low light and night vision. Once the light or the image hit the photoreceptor, those will transduce the light and the image. Then it will transfer to the bipolar and then to the ganglion cell layer. The ganglion cell layer then will form the optic nerve. The optic nerve will be composed of these fibers. Mostly the temporal regions will pass without crossing. The nasal part will mostly will be crossing the optic chiasm. Going forward, the optic nerve, after the optic chiasm, will give us the optic tract, and the optic tract fibers will synapse in the lateral genicular nucleus on this side, and from there these fibers will have a couple of radiations that will take the inferior radiations from this nerve, from these fibers, which is also called Mayer's loop. This will conduct their impulses to the lower bunk of the calcarine fissure in the primary visual cortex in the occipital lobe, or That is also called the lingual gyrus. And then there is the superior uh, radiation, which will transform these lights, conduct the impulses to the upper bank of the calcarean fissure, which is also called Cuneus gyrus on both sides. The visual area, which is the primary visual area, which is Brodmann area 17 in the occipital lobe, would receive these radiations. And from here, the radiations will go into one of these direction. The radiations will go from the lateral genicle, from the occipital from the occipital lobe, the visual area. These radiations will go into the dorsal way for the association cortex in the parietal lobe. And this association cortex will figure out where, which is the spatial orientations and motion, while the other fibers, which will be taken to the so this was the dorsal pathway, and the ventral pathway will conduct these impulses to the association for cortex in the temporal lobe. And here we're gonna know what the color and the shape of the object. The visual pathway could have some defect while conducting these fibers. For example, if we have if we knock out the optic nerve here, we're gonna have anopsia, which is complete blindness in the left eye, or maybe right eye if we knock out the right optic nerve. If the problem is in the optic chiasm, then we will lose half of the visual field, both temporal halves of the visual field will be lost, and this will be called bitemporal hemanopsia or tunnel vision. If we we move forward and we knock out, for example, the major lobe here, then we're going to have visual defect. The visual field will be what we call the superior contralateral side from the lesion. In this case, will be the upper superior homonymous quadrant tenopsia. If we knock out the superior radiation here, then we're going to have inferior quadrant tenopsia, homonymous quadrant tenopsia. If we're having a problem with the whole radiation on one side, for example, this is the right side, you're gonna end up having homonymous, the left side with macula sparing because of the dual blood supply to the macula. If we knock out one of the optic tract, we're going to have visual field defect, which is both left visual field, and this is what we call the homonymous, the right homonymous for the optic tract lesion. And I think that's very much about the visual field and visual field defect. Thank you very much.